And so now let's talk about a few more examples. So malleability, as I mentioned earlier, is just the ability of a substance to be hammered into a thin sheet. So gold is definitely an example of that because because of jewelry, it is shaped into pretty much any shape imaginable. Right. Then you have melting and freezing points. These are the temperatures at which a solid becomes a liquid and a liquid becomes a solid. So freezing and melting points, and you're not changing the identity of a substance. You're just going from like solid H2O to liquid H2O to gas H2O, but you're not changing the identity of the subject. Density is the density of a substance is measures how close together its particles are, right? So the higher the density, that just means the particles are more tightly packed in, and those are more likely to sink to the bottom. So like here, you probably have like oil or something at that very bottom level, and at the very top, you probably have like either some colored water or some really light oil, and so that is low density. So it's going to kind of float to the top there of the mix that you have, the mixture. And so a physical change is just a change in the appearance without changing the identity of the material, right? So if you remember right here, the definition of a physical property, it's the property of something, right? Just something that kind of defines it that you can observe easily, right? You don't have to kind of go into the microscopic level and start pulling things apart. No, it's just kind of an observation that you make. So, but this is a physical change. So this is a change in the appearance of a material, but without actually changing the identity of that material, right? And these can be reversible or irreversible. And substances may seem different, but the way the atoms link up is the same, right? So an example of that could be ice versus liquid water versus steam, right? It may seem like they're all different, but the atoms are all linked up in the same way, right? It's still H2O. And so it is a physical change if it changes shape or size, right? If it dissolves or the substance changes phases, again, like solid, liquid, gas. And so you look at some of the examples here in the pictures, you have breaking glass. It's still going to be glass, right? It's just going to be broken into multiple pieces. Same thing with something like mixing candies. You're still dealing with the same amount of candies, you're just moving them in a different arrangement. Shredding paper, same thing. It's still paper. You're just turning it from one large sheet into a bunch of thin strips of paper. Same thing with that origami swan you see. It's paper. It's just folded. Ice, whether it's solid, liquid, or gas, is going to be H2O. And then chopping wood, just turning it smaller, cutting your hair, just making it shorter. Dry ice is just going from a solid to a gas. Boiling water from a liquid to a gas, still H2O. And then breaking the egg, still made of the same stuff. It's just now into different pieces. Right? And so some examples of chemical properties are, and again, a chemical property, just any ability to produce a change in the identity of the matter. And so we talked about physical properties and physical changes. Now let's talk about chemical properties. So, a chemical property is any ability to produce a change in the identity of matter, right? So, this is if you're going from like H2O to H2O2, you're actually changing the identity of the matter, right? So, like I said earlier, H2O is water, but when you add that extra oxygen to it, you get H2 and then O2, that becomes hydrogen peroxide, right? So, you change the whole identity of the matter. And so some examples of chemical properties include flammability, right? So the material's ability to burn in the presence of oxygen. That is a chemical property. Reactivity is just how readily a substance combines chemically with other substances. And this I showed you earlier when we were talking about the reactivity, and I showed that image of sodium being dropped into water and it just kind of goes up in flames, right? Like a little mini explosion. So here you actually see sodium as the second of the most reactive substances on this list. And so everything in here is uh, ranked in order from most reactive to least reactive. And again, reactivity is a chemical property. And then if something is corrosive, it basically means that it can eat away at something such as metal by acid, right? So if something is corrosive, then that is one of its chemical properties, as that is that it is corrosive, right? So again, acid is corrosive. That is one of its chemical properties. And so now let's talk a little bit about the chemical changes. So chemical changes occur when a substance reacts and forms one or more new substance, right? So you know that a chemical change has occurred when there is a change in color or odor, right? So something you can think of is like milk, right? If you have milk sitting out in the counter when it's first set out there, it's going to be like a white, thick substance, right? Milk is a little bit thick depending on the kind of milk. But as it changes, is it starts to get rotten, right? It starts to go bad. You will notice that it starts to turn like a greenish color. And then there's also like a change in the odor, right? So like milk starts to smell sour. Sometimes a gas is produced. Sometimes formation of a precipitate or a solid, and you can kind of see that in milk too. With that same example, is that usually chunks of milk of something start to form, a precipitate start to form in that rotting milk, and then it absorbs or releases energy such as getting hot or cold, or light is given off. And an example of this is when you light a match, right? When you light that match, you see that, or you feel the heat coming from that match, but you also realize that a light is being given off when you strike that match. And so that's an example of a chemical change, right? And you're changing the very substance of the match, especially if you let it burn down into ashes, right? It's no longer made of the same composition, right? It's no longer wood, it is now ashes. So let's see some examples of chemical changes. So again, chemical change, you're changing the substance, the materials, the composition of the material, right? Like the very structure of it. So when it comes to like burning or combustion, you can consider that a chemical change because it has a color change. There is an odor change. It produces a gas and it gets hot, right? So these are all characteristics of a chemical change occurring. There is also a corroding, right? If something is corroding, then that means it is going from, like, think of this metal here, right? It's going from this shiny, sturdy material into this dark, burnt orange, brown color, and it's no longer sturdy. Now you can kind of like punch through it without a lot of effort if it is especially corroded. And then you see rusting, that is a color change. Again, you're going from like a shiny metal to something that is no longer shiny, right? It's this dull, burnt orange color. That is a characteristic of a chemical change. Another color change that's showing that there is a chemical change happening is in mold. So if you really zoom into mold, you'll notice that you'll start to see a color change. If you think of a slice of bread that has gone moldy, you'll notice at first just a white piece of bread, but as it starts getting more moldy, it changes colors to like a greenish, gray color, right? So you have that color change. Decay is also an example of a chemical change. So if something is decaying, it's no longer like, you see this fruit here. It looks like an apple or a pear. It was once a lot more firm, a lot more a light color, but now that it's decaying, right, it's becoming a lot more like mushy, not as sturdy. The color change is getting darker. The very center looks like a black color, and then kind of starts like radiating brown color out of that. So that is a color change, and that's showing an example of a chemical change. Digesting is another example of a chemical change, right? So here, the food that you eat, it goes during the process of digesting, it undergoes a color change, it undergoes an odor change, and it produces a gas, right? And so, but the reason why it's so important to us is because it releases energy, which fuels us, right? And that energy that is created is an example of a chemical change. So, really quick, what kind of change is this right here? So, if you answered physical, right, this is a physical change. What kind of change is this right here? If you answered chemical, you're right, this is a chemical change. And what kind of change do you see here? If you answered physical, then you're right, this is a physical change. Right, it's going from a solid to a liquid. And then this right here, which is this? This is a chemical, right? Because you see the bubbles again are a sign that there's a chemical change happening. So this is a chemical change. What kind of change is this right here? So this change that you see right here, if you answered physical, then you're right. This is a physical change.